Okay, good morning class. So today this is part 2 of the video for simplifying radicals with multiplication and division. We're just going to jump right into it. Okay, example A. The fourth root of a to the 8th, b to the 10th, c to the 15th times the fourth root of 2a cubed b. This is to the fourth root, this is to the fourth root. Since they're the same index, we're simply just going to multiply what's under the radicals, and then we're going to simplify later. So the fourth root of 8 times 2, which is 16. A to the 8th times a cubed is a to the 11th. B to the 10th times b is b to the 11th. C to the 15th. So we have the fourth root of 16, a to the 11th, b to the 11th, c to the 15th. Now, we're just going to break that down into two radicals. Everything that's a perfect fourth root, I'm going to place under my first radical. Everything that's not a perfect fourth root, I'm going to place under my second radical. 16 is a perfect fourth root, so I'll place it here. Out of the a to the 11th, I'll take a to the 8th, which is a perfect fourth root, put a cubed here. B to the 11th, I'll take b to the 8th, put the b cubed here. And for c to the 15th, I'll take c to the 12th and put a c cubed here. Because all of these are perfect fourth roots, these are not. Then I'll just simplify this. The fourth root of 16 is 2. The fourth root of a to the 8th is a squared. The fourth root of b to the 8th is b squared. The fourth root of c to the 12th is c cubed. And then we just simply bring over the fourth root of a cubed, b cubed, c cubed. So our final answer, 2a squared, b squared, c cubed, the fourth root, a cubed, b cubed, c cubed. Okay? Now I'm going to move over to D. I'm just going to go down this way. All right? Here we have the cubed root of 162y to the 5th divided by the cubed root of 3y squared. This is the index of 3. This is an index of 3. Same index, so I'm going to divide what's under these radicals here. 162 divided by 3 is 54. Y to the 5th divided by y squared is y to the 5 minus 2, which is y cubed. So I have the cubed root of 54y cubed. So I'm going to break that down into two radicals. Everything that's a perfect cube, I'll place in my first radical. Everything that's not a perfect cube, I'm going to place in my second radical. Now, the cube root of 54, I'm going to break down as the cube root of 27 times the cube root of 2. Because 27 times 2 is 54, and 27 is a perfect cube. Y cubed, I'm going to place right here. So now I'll simplify my first radical. The cubed root of 27 is 3. The cubed root of y cubed is just y. Then I just bring this over. The cubed root of 2. So our final answer here, 3y cubed root of 2. Okay? Hopefully this makes sense. Let's move forward here. Now let's go down to B. So we have negative 2 times the cubed root of 27 ab cubed times 4, the cubed root of 5a to the 4th b. Now the negative 2 times 4, that's negative 8. That's easy. This is a cube, this is a cube, same index, so I'm going to multiply what's under them and then simplify them later. All right? So 27 times 5 is 135. A times a to the 4th is a to the 5th. B cubed times b is b to the 4th. So what I have now is negative 8 times the cube root of 135, a to the 5th, b to the 4th, and now I'm going to simplify it. I'm simply going to bring over the negative 8. Now my cubed, I'm going to break it into two radicals. 135 I'm going to break down as the cube root of 27 times the cube root of 5. A to the 5th, I'm going to break down as a cubed and put a squared over here. B to the 4th, I'm going to put b cubed here and the other b right here. So now I have negative 8 times the cubed root of 27 a cubed b cubed, the cubed root of 5a squared b. Break this down right here. Just bring over the negative 8. Now, the cubed root of 27 is 3. The cubed root of a cubed is a. The cubed root of b cubed is b. Then I just bring over the cubed root of 5a squared b. And then I just multiply the negative 8 times 3. My final answer, negative 24, AB times the cube root of 5a squared b. And hopefully this is becoming more straightforward to you as we do more of these examples. Let's move over to E. I'm going to jump over to E here. So I have the square root of 72 x cubed y squared times the square root of 10xy cubed. Again, this is a square, this is a square, same index. I'm going to multiply what's under them. 72 times 10 is 720. X cubed times x is x to the fourth. Y squared times y cubed is y to the fifth. So now I have the square root of 720 x to the fourth, y to the fifth. I'm going to break that into two radicals. Everything that's a perfect square will be under the first radical. Everything that's not a perfect square under my second radical. 720, I'm going to break down as the square root of 144 times the square root of 5, because 144 times 5 is 720, and 144 is a perfect square. X to the fourth is a perfect square. I place that here. Under y to the fifth, I'm going to take out y to the fourth, which is a perfect square, and place the remaining y here. Then I just break this down. The square root of 144, x to the fourth, y to the fourth. Well, square root of 144 is 12. Square root of x to the fourth is x squared. Square root of y to the fourth is y squared. Then just bring down the square root of 5y. Final answer, 12x squared y squared, the square root of 5y. All right, let's go over to C. Let's move down here. With C, I have 5 times the square root of 18x to the fifth divided by 2, the square root of 2x cubed. Now the 5 and 2, I'll just bring them over. Now, since this is a square, this is a square, I'm going to divide these two here. 18 divided by 2 is 9. X to the fifth divided by x cubed is x to the 5 minus 3, so that's x squared. So I have 5 to the square root of 9x squared divided by 2, because again I just moved over the 5 and the 2. Now the square root of 9x squared can break down easily. I just bring the 5 over. The square root of 9 is 3. The square root of x squared is x. So in my numerator I have 5 times 3x over 2, simplified to be 15x over 2. And hopefully you didn't have any difficulty with that. That one was pretty straightforward. Now look at F. F is a little bit more complex, but you should be able to follow me. We have 10 times the cubed root of 64 a to the 12th b to the 6th divided by 2, the cubed root of 2a squared b to the 6th. 10 and 2 just work out to be 5 and 1 are just 5. So I just simplified the 10 and 2 just to get that out of the way. Now, we have the cubed root of 64a to the 12th b to the 6th divided by the cubed root of 2a squared b to the 6th. Since they're both to the same index of 3, I'm just going to divide these two. 64 divided by 2, 32. A to the 12th divided by a squared is a to the 12 minus 2, a to the 10th. B to the 6 divided by b to the 6 is just 1. They cancel each other out. So what we have right now is 5 times the cubed root, 32a to the 10th. Now, let's bring it down further. We just bring the 5 over. Now, the cubed root of 32a to the 10th, I'm going to break that out into two radicals. Again, the first radical is going to be everything that's a perfect cube. Everything that's not a perfect cube is under my second radical. Now, the cube root of 32 I would break down as the cube root of 8 times the cube root of 4, because 8 times 4 is 32 and 8 is a perfect cube. A to the 10th I would break down to a to the 9th, which is a perfect cube, and put the remaining a under the other radical. Then I would simplify this. I bring my 5 over. Now the cube root of 8 is 2. The cube root of a to the 9th is a cubed. Then I would just bring the cube root of 4a over. So I have 5 times 2a cubed, the cubed root of 4a That simply simplifies to be, come on here, 10a cubed, the cubed root of 4a. Okay, I'm going to stop right here with this one. I'm going to go on to part 3. See you guys with the next video.